So that's the end of point 2. Okay, the last thing I want to do in the last half hour we have is to now introduce a related class of functions. Remember, we talked about early in chapter 1 a function and its inverse functions. So now we move on to 3.3, and we're going to introduce a new class of functions called the inverse trig functions. So remember what they were. We introduced them in 2 different ways. We had a function, y equal to f of x, and you had your domain x, and then your range, your y values. All the x's there was in point. Now, if you wanted to introduce another function, what did you do? You swap the x's and y's. So you dealt with an inverse function, and you defined it in this way. X and y swap their roles. So you got x is equal to f of y. And they swap their roles over here. So my domain now turned out to be my y values, and my range was the x values. That was equivalent to taking our graph, so whatever graph we might have had, and rotating it about the line y equal to x. Everything's going to be the same. We learned how to do that with some simple ones. Now we're going to expand that idea. So say I had a function that looks something like this. And I wanted to find its inverse. I would flip it about that line, y equal to x over here, and we would get something that looks something like this. That would be my inverse function. And we gave it a strange representation. So if this is the graph of this is my f of x, we call the green line my inverse function, and it's not a reciprocal. Remember, it's f inverse of x. That does not represent 1 over f of x. You got to be careful. We're using this negative symbol in a different way. So you have to stop and think. Is it reciprocal or is it inverse? If I want this, I write it very precisely like this. If I want that, that is equal to, I take my f of x, and then I take the inverse of everything, or the reciprocal. We call it inverse, but we should say reciprocal. We do that all the time. Inverse and reciprocal do not mean the same thing, although we use the language as if we're talking about it as if they are. But you got to be careful. Okay, so we have our sine function. Does it have an inverse? Remember, it has to satisfy that property. So let's take a look at the sine function now. Sine of theta. What does the inverse function of that look like? And I'm going to write it this way. Sine inverse function of theta. Again, that does not equal to 1 over the sine, otherwise that would be the cosecant. It's something different. It's this flipping of the x's and y's. Okay, let's take a look at it graphically. So I'm going to go on now to, if you will, Desmos, and look at the function and add in those pieces. So here's my Desmos, and what I have highlighted there is y is equal to the sine of x. That's in blue. And I'm going from essentially minus 3 pi up to 3 pi, and the same axis here. This is from 2 pi, minus 2 pi to 2 pi. Here's my line, y equal to x. Now if I take and rotate this blue line about the purple line, I will get this. All I need to do is switch the x and the y. Y becomes x becomes y. This is my inverse function. So let me just get rid of these two, and this is the function I'm dealing with now. It's now the sine graphed along the y-axis. Now the problem with this, if I kind of zoom in over here a little bit, excuse me, is it's not a function, is it? If I look over here, if I draw a vertical line, such as, x equal to 1, or x is equal to 1/2, say 0.5, you can see I hit at more than one location. So that's a problem. I can't have that happening because look at it. It intersects at an infinite number of locations all throughout over here. So what do we have to do? Well, we're going to have to restrict what we call the domain of this function. The input values are only going to be for a certain, what I put in is only going to be through a certain values of these. The domain and the range, if you will. So we're going to have to put a restriction on what can come out. And what we're going to restrict, and I'm going to put it now as a sine function, the arc sine. So let's now draw the graph of y equal to, and now let's use our calculator so you can kind of see the functions and the trig functions that are over here, and there it is. That means the inverse sine, not the reciprocal. And here the cosecant, secant, etc. But I'm going to use this. And we'll now put my y, sine inverse of x. And then you can see the black line is just a limited portion of that green graph there. So now it's just this portion. And what does that go through? Well, if I just have the black line as my function, notice when I draw my vertical line, it only crosses at once. So I'm eliminating all the pieces down. So I have to restrict that. So the inputs go from what to what? Well, if I look at what this value is, you're not going to see it in here, but that value is, you can see right there, minus my y value over here, though the height down there is going from minus pi over 2, okay, to my plus pi over 2, right over there. So that's where we have it. That's the output of my function. The output is always going to be the opposite. So let me kind of do this now and talk about this without this. Go back to the board. So that's a picture there to kind of get you a sense for what we're looking at. So now we have a picture of what that looks like. And now let's understand what it's giving us. Let's start talking about the domains and the ranges of these. And I think, well, maybe I'll go back to this and go back to our, if you will, go back to our screen here. But now we're going to look in our textbook. I'm kind of bring you to our textbook over here. And go back to the unit circle. So we have this in our textbook in the unit circle. What are we doing? We are putting in the input is not theta. The input is the coordinate of that, and we want the output is the angle theta. We're trying to find what angle theta is associated with the y coordinates all along that unit circle, the second coordinate. So for example, if I put in this arc sine, the inverse sine of 1/2, I'm at the angle 30 degrees, or pi over 6. If I put in the inverse sine of the square root of 2 over 2, meaning 0.707 approximately, I will get 45 degrees, or pi over 4. So if I put in the second coordinate, it's telling me I'm going to get out the angle. It undoes it. Instead of putting in a value, an angle, and getting out a number, we're now putting in a number and getting out the angle. So for example, if I put in minus the square root of 3 over 2 in quadrant 2, that's going to give me the angle of 150 degrees, or 5 pi over 6. So that's it. It's confusing, but take your time and kind of figure it out appropriately there. Let's talk about that some more now. So just to be clear, here, we put in an angle. That's my domain value. And we get out a number, some number between, a number between -1 and, put it the y value, doesn't matter, and +1. That's the sum. Put in an angle, get out a number between -1 and 1. Goes the height going up and down. The arc sign, it flips it around. Here, for your domain, this is a range, of course. The domain is you put in a number, some number between, -1 and +1. Theta is no longer an angle here. It's a number. We interpret it that way. And what do you get out? Well, you get out an angle. Its range is an angle. And you can get any sort of angle out, depending upon where you are in that unit circle, how many times you want to round. So that's the whole thing. But we're going to restrict the angles you're going to get. Because if you could get any angle, then you could get things that are not a function. So this is where we're going to restrict. We're only going to give you an angle between, minus 90 degrees and plus 90 degrees. Or, in this case, minus pi/2. In fact, we won't even get you to 90 degrees. We'll get you close to it. Yeah, I'll put it there. And then you get minus pi/2, which is minus the equivalent in radian measure with the arc sign, and plus pi/2. So that's what we're having. It's a little bit different. So let's take a look at some examples of these. Say, for example, someone says, can you tell me what this arc sine, or yes, I should say sine inverse, is also given the names. Let's put this first. So arc sine is some number. Sine inverse is also called the ARC, arc sine. So sometimes you'll see it the arc sine of x or something like that, SIN. This and that mean the same thing. They're just two different ways of referencing it. For the most part, we use this. This is a nicer notation because it doesn't confuse the inverse, but it's longer to write. This is much simpler to write. So, for example, someone says, find the arc sine of 1/2. Well, I know it's associated with an angle. My output, that's my input, is 1/2. My input is a radian measure, not of an angle, just of a number. And the output has to give me an angle. So my domain over here is what I can put in, numbers between -1 and +1. And what comes out will be an angle. So if I wanted to think about what was happening, I could think about this on a unit circle. Now, I want my value for my height over here to be 1/2. I'll put a half over here. That's 1/2. And I draw that line over here and to figure that angle. What is that angle theta that comes out? Well, that angle theta that comes out is equal to 30 degrees. So if you have it set on your calculator for degree measure, that's 30 degrees. Or in radian measure, it's pi/6. The output of the arc sine will only give me values between plus 90 and minus 90. So this is my output. That's my range, if you will, of the arc sine or sine inverse of some angle, of some x value, if you will. Have to be careful. So I'm saying that if I had my coordinate over here, the y coordinate over there is 1/2. 1/2 is associated with an angle of 30 degrees or pi/6. Now what happens if I do this? Here's an example. What happens if I change this a little bit and do the sine inverse of 1.5? Well, notice that is not in the domain. The domain has to be between -1 and +1. That's out of it. So what's going to happen? Let's go to your calculator and see. That's putting it in radians. The arc sine, always radians go in. What comes out will be an angle in whatever your calculator is set in, either radians or degrees. So coming over here, so I'll turn this on, and right now I'm set in the mode for radians. Yeah, and let me just kind of go through, just kind of show you how to do it. Make sure it's in radian measure, and then we're going to set it to degrees, so you can kind of see the same thing. If I plug it in, I'm going to get a problem. So I'm set for radians, and you're going to see this is going to be a problem. So now I'm going to take here it is, behind the sine is that blue, sine inverse, and this is going to give me a problem. I'm plugging in this value, and if I look at what's coming out, error in the domain. I cannot put in a value greater than 1 or less than -1. It's a domain error. That is not in its domain. I have to be within the domain of the sine function, meaning I could put in the sine inverse. Let's do it over here, the second function sine inverse of 1, and I would expect to get 90, but now in this, instead of 90 degrees, I'm going to get 90 degrees written in radian measures, which is pi over 2. So it's 1.57. Now, if I wanted it to give it to me in degree measure, I would set my calculator for degree measure instead of the radian measure over here. Oops, I got one more. And then when I do that and do, say, the arc sine or the sine inverse of 1, it will tell me 90. It doesn't write the degree symbol, but I have to interpret it to be 90 degrees. Got to be very, very careful. We have a restricted domain. I can't put in any number, and my output, my range is also restricted. So I have a domain that is not, from minus infinity to plus infinity, and my range is different as well. What comes out of here will just give me from minus 90 to plus 90. Okay. So it's a little bit confusing here for a lot of students. So in this case, the answer is undefined. I'm trying to put something in the domain, because essentially I'm doing this. If you want to look at what I'm doing, it's this. Go back to the unit circle. My function only lives on this part of the unit circle. Okay? It has to be on those coordinates, and here my point over here is 0, 1, 1, 0, 0, -1. So it's a unit circle, so that distance there is 1. So I'm saying, what if this, if I put in a value for my y coordinate at 1.5? I'll come over here, 1.5. That is not on the graph. That's not on the red line. It's outside of the domain. It's not working. It has to be a point on that, red line here, that red curve over here, to be satisfied in here. That's outside of it, so there is no angle associated with that. No angle is associated with that, because it could be here. We're just going out a distance of 1.5. My y coordinate is 1.5. It could be here. It could be there. Just my height is 1.5. It's not going to give me anything that makes sense. But if I bring it into the arc sine or sine inverse of 1, then it moves this point right there, and it gives me my output angle that's associated. Now, that's what I'm putting in 1 in, and the output angle over here is my 90 degrees. That's the angle associated with it, which I can also write in radian measure as pi over 2. So that's it. So that is my arc sine. In a similar fashion, we can also do the same thing for the cosine, but then we have a restricted domain and range as well. And I'll give you some of these to try. I know these will give you a little bit of problem, but we'll go over them. And let's do the same thing. I'm just going to switch everything from sine to the cosine, and you kind of see what's happening over here. That's not what I want. Yeah, same sort of thing. Now for the cosine, I will put in, again, a value between -1 and 1. This is along the x-axis, so it's the first coordinate, and I'll try and get an angle out. But where that develops into a problem is if it is still a function or not. So I'm going to just change everything over here. Let's get rid of that, rid of this, and I'll put everything as a cosine. And then I'll show you the graphs of each of those respectively. Okay, so here's the graph of the cosine. Here's the line y equal to x. I'm going to rotate that graph about that, the blue one about the purple line, and it looks like this. That's what I'm going to call my inverse cosine. I'll put it over here, but notice this again is not a function, because if I draw a vertical line, I will intersect the green line at more than one location. So what do I have to do? I have to restrict the output of that. And here's why, when I restrict it, I only get this part of the curve, the black. That's what I'm going to choose to be my kind of related to the domain and range of the cosine. So this is my, what my arc cosine, a cosine inverse looks like, if you will. So let's go back and just make some sense out of that now. So now we're going to look at the cosine inverse, or sometimes we call it the arc cosine. The domain is what we can put in. So the domain for this is very similar to the arc sine. The domain is the set of all elements x, that's that x is a real number, but it has to be a real number between -1 and +1. Anything out of that, it will not work. So I put in a number, and the range gives me an output angle. Range is an angle that comes out. So the range, I'll call those y values if we wanted to. Not really my x and y is associated with the graph. It's more that just kind of a generic y. And the range is all, y is a real number. But if I use my, I'll do it in two different ways so you can see it, angles and radians. So what I'm going to get, I can get either an angle out of 0, less than or equal to y, which is less than or equal to pi, 180, or 0 is less than or equal to y, is less than or equal to, this is 0 degrees, which is less than or equal to 180 degrees. So depending upon what angle, either in radian measure or degree measure. That depends upon what you have your calculator set for. And in a similar fashion, I'll write this next to it so we can compare the two together. Now, it was arbitrary. That was arbitrarily chosen to give you those angles. They are different. So here's my arc sine, or sine inverse x. Similar, the domains are the same. The D is the set of all elements. X, that's that x is a real number, but x is between -1 and 1, inclusively. And the range for this is different. So the range over here is a set of all elements y. Y is a real number. But if I write it in both ways, I put minus pi over 2 less than or equal to y is less than pi over 2. Or if I use degree measure, minus 90 degrees less than or equal to y less than or equal to plus 90 degrees. It gets a little bit confusing, but that's the way it is. And I'll put the last one, we have our tangent inverse. We have an inverse function that will undo the tangent. Now, the domain over here, you can put anything into the tangent. I'm going to show you that in a second. So the domain is the tangent is any real number. So D is a set of all elements X, such as X can be a real number. Because remember, the output of the tangent is a real number, so the input of that will be a real number. You're swapping the domains and ranges, if you will. Now, for the range over here, we're going to find we have to also choose this in a very precise way. Otherwise, it's not a function. The range is going to be the same as the arc sine. So it's going to be set of all elements y. Y is a real number. But we're going to restrict it to be between minus 90 and plus 90. Or minus pi over 2 and plus pi over 2. And let's take a look at the graph of that. And I'll show you the same thing we were just doing in the remaining 5 minutes here. So now I'll just replace everything here with tangent. Same sort of thing. This is a very simple way to visualize a function and its inverse by swapping the x and y coordinates out and what you get. Okay, so we start by drawing the tangent function. That's what it looks like. Line y equal to x. Now we flip the tangent about that line by swapping the x and y coordinates. So I highlight this. That's what it looks like. Let's get rid of the other two aspects. That's not a function. Notice I can hit it infinite number of places. So what do? I restrict the output of that, and that's it. It's going to go from, minus 2, this value over here. If I plug in the line, say, y equal to, and we don't quite, I got to be careful over here. We don't quite hit that. It's not equal to pi over 2. It gets closer and closer to that as the input gets closer to infinity. So technically speaking, for these over here, I have to be a little bit careful. I'll never get to that, only if I put in infinity. And a similar thing will apply for the sines as well. That's the sort of thing you'd have to, well, sine it doesn't worry about. This tangent, you can't quite get to having a value of plus 90 or minus 90. It will not be acceptable. Okay, so that kind of gives you, we'll come back to these again. This won't be the end of what you'll see. We will come back to these again. That kind of just shows you everything that we wanted to cover today about the inverse trig functions. Inverse cosine, inverse sine, inverse tangent. Dealing with their domains and their ranges. You can easily use technology to see their picture.